In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, Exponents and Division. Now, our directions for this worksheet are to simplify, and your answer should contain only positive exponents. So let's remember that our answer needs to be written with positive exponents. Before we jump in, let's recall that when we did exponents with multiplication, where we were multiplying terms, where the bases of those exponents were the same, like x squared times x cubed, we have the same base of x. What did we do to those exponents? If you don't remember, I'll leave a link to the previous video. However, what we do to those exponents is we add them together when those bases are getting multiplied. So we have x to the 2 plus 3, which equals x to the 5th. So when multiplying, we add the exponents. What do you think when we divide? When we divide, we will be subtracting the exponents. Now, I want to mention that adding the exponents, addition's commutative, right? We can add 2 plus 3, and that's the same exact thing as 3 plus 2. However, 2 minus 3 is not the same as 3 minus 2. So when we're subtracting those exponents, because on this worksheet we're going to be doing division, we need to take the exponent in the numerator and subtract the exponent in the denominator. So let's dive into number 1, going over this a little more in depth. So number 1, you can see we have 5 to the 4th divided by 5. Remember, this 5 we could also write as 5 to the 1st. 5 to the 1st power, an exponent of 1. So when we're dividing and we have the same base, you can see that 5 and 5 are indeed the same number. 5 to the 4th divided by 5 to the 1st is equal to 5 to the 4 minus 1, the exponent in the numerator of 4 minus the exponent in the denominator of 1. And that's going to give us 5 to the 4 minus 1 is 5 cubed. So 5 cubed is our answer for number 1. And visually, if you want to see this worked out, think about 5 to the 4th. That numerator is 5 times 5 times 5 times 5. So 5 multiplied together 4 separate times. And in the denominator, we have 5 to the 1st, which is simply just 5. From this, we can simplify down by crossing out 1 5 in the numerator and 1 5 in the denominator to leave us with just simply a 5 cubed. Let's move on to number 2. For number 2, we have 3 divided by 3 cubed. So that's 3 to the 1st over 3 cubed, which we take the exponent in the numerator and subtract that exponent in the denominator. So our base is 3, and we're going to have 3 to the numerator's exponent of 1 minus the denominator's exponent of 3. Exponent on the top minus the exponent on the bottom. 3 to the 1 minus 3 is 3 to the, 1 minus 3 is a negative 2. So we have 3 to the negative 2. But wait a second, that's not quite the solution they're looking for on this worksheet, because it says that our answer needs to contain only positive exponents. So how do we change this negative exponent into a positive exponent? Well, whenever we have a negative exponent, that's the same as having this in the denominator, but to a positive exponent. So 3 to the negative is equivalent to 1 over 3 to that positive exponent, or 3 squared. So our answer is 1 over 3 squared in this solution. Now let's look at this visually, just to help you out. So 3 to the 1st is 3. Divide that by 3 cubed, which is 3 times 3 times 3. When I cancel out the 3's that can be canceled out, I'm canceling out my 3 in my numerator with one of my 3's in my denominator to leave me with a 3 squared, but that's underneath my fraction bar, so it's 1 over that 3 squared, 1 over 3 squared. So again, noting if we had a variable x raised to a power of, let's say, a negative 5, all we're going to do is write this in fraction form so that we can have a positive exponent as 1 over x to the positive exponent, so 1 over x to the 5th. So remembering that, let's continue on to number 3. For number 3, we have 2 squared over 2 cubed. Let's start visually picturing what this is going to be. 2 squared is 2 times 2, and 2 cubed is 2 times 2 times 2. So when I cancel out my 2's in my numerator with my 2's in my denominator, 2 of those in the denominator will get canceled out with 2 in the numerator. 2 2's cancel out with those 2 2's to leave me with a 2 in my denominator, or a 2 to the first. So this is going to be 1/2. But I didn't need to write all of this out to figure out that it's going to be 1/2. We can use the property of dividing with exponents. So 2 squared and 2 cubed, I have the same base in the numerator and denominator, so I can have 2 to the 2 minus 3. 2 to the 2 minus 3 is 2 to the negative 1, because 2 minus 3 is negative 1. And how do we write that? Well, it's simply 1 over 2 to the first, or 1 over 2. So visualizing is very helpful, but think about if we had a number like 2 to the 11th over 2 to the 23rd. Writing out 11 2's and then 23 2's and canceling out would be very tedious. That's where this subtraction of exponents is really handy. Let's move on to number 4. In number 4, we have 2 to the 4th over 2 squared. 2 to the 4th over 2 squared, we have the same base of 2, so we can write this as 2 to the 4 minus 2, which 2 to the 4 minus 2 is 2 squared. So 2 squared is our solution in number 4. And writing this out visually one more time, just so you can see, we'll have 2 times 2 times 2 times 2 all over 2 times 2. 2 2's in the numerator cancel out with 2 2's in the denominator to leave me with 2 squared. In number 5, we're starting to throw in some variables into these problems, but the same concept applies. If we have 3 times r cubed over 2 times r, what is our similar base? Our similar base in each is the r. We have r cubed and we have r to the first. This 3 over 2 is just coefficients out in front, so we can just leave them for now. So we're going to have 3 over 2 times r cubed over r to the first. All I did was split that fraction up so you can visually see how we're going to deal with those exponents. So we're going to have 3/2 times r to the 3 minus 1. So 3/2 times r to the 3 minus 1 is 3/2 times r squared, which this r squared does indeed have a positive exponent, so we can just put that back into the numerator. So we get 3r squared over 2 as our solution for number 5. 3 times r times r times r over 2 times r. All we can cancel out is one of those r's in the numerator with one of the r's in the denominator to leave us with 3r squared all over 2. In number 6, we have 7k squared over 4k cubed. I'm going to break my fraction up as 7 over 4 multiplied by k squared over k cubed. Now, working with exponents that have that same base of k, we're going to get 7 over 4 times k to the, well, it's going to be 2 minus 3, because 2 is the exponent in our numerator and 3 is the exponent in our denominator. So this is going to equal 7/4 times k to the 2 minus 3, which is k to the negative first. Remember though, we don't want negative exponents. How would I rewrite k so that I don't have a negative exponent? Well, k to the negative first is 1 over k to the positive 1. So I'm going to have 7/4 times 1 over k to the positive exponent, so to the positive 1, which, finishing out this multiplication, is just 7 over 4 times k, or 7 over 4k. You can see here that because I have more k's in my denominator than I do in my numerator, that ultimately in the end, I'm going to have some k remaining in my denominator, but all the k's in my numerator will get canceled out. Moving on to number 7, where do you think that p is going to remain? Is it going to remain in my numerator or my denominator? It's going to remain in my numerator because I have more p's in my numerator than I do in my denominator. So this p in the denominator eventually is going to get canceled out. But let's go ahead and work out this math. Splitting up my fraction, I have 10 over 6 times p to the 4th over p to the 1st. That's 10/6. But as opposed to writing this as 10/6, this fraction actually simplifies down because both 10 and 6 are divisible by 2. So dividing 10 by 2 is going to give me 5, and dividing 6 by 2 is going to give me 3. So what I did here was I just simplified this fraction down a bit since I had common factors in both 10 and 6, and that common factor was 2. So I have 5/3 times p to the 4 minus 1. So that's going to be 5/3 times p to the, 4 minus 1 is 3, so p cubed. Again, because this is positive exponent, I can put it right back up in my numerator. So I get 5 times p cubed all over 3. Let's move on to number 8. And number 8, where do you think I'm going to still have b remaining? In my denominator, because I have more b's in my denominator than my numerator, so I know those are going to get canceled out. Because again, I have that same base of b. So we're going to have 3/10 times b over b cubed. That's going to be equal to 3/10 can't be simplified down, so 3/10 times b to the, this b is like a b to the 1st, so that exponent of 1 minus the exponent of 3. That's going to give me 3/10 times b to the negative 2. And how are our answers supposed to be formed? Only with positive exponents. And how do we rewrite a negative exponent? Well, we just move that base into the denominator and write the exponent as positive. So this is going to be 3/10 times 1 over b to the positive 2, flipping that sign from a negative 2 to a positive 2, since I moved this into the denominator of a fraction. So I have 3 times 1, which is 3, over 10 times b squared, so 10b squared. 3 over 10b squared is my solution for number 8. Now quickly, as a side note, let's think about if we had a fraction like 1 over x, but the exponent within our fraction was a negative, so 1 over x to the negative 5th. In order to turn this to a positive exponent, we have to move it into the numerator and switch that sign. So this is the same as x to the positive 5th. So just how we have an x to the negative 5th, we turn it into 1 over x to the 5th. If we have 1 over x to the negative 5th, we can turn it into simply x to the 5th. And that being said, we could have started by moving this b cubed up into our numerator. We could have rewritten this problem as 3 times b to the negative 3 all over 10. Because remember, like I said, 1 over b cubed is the same as b to the negative 3. And then, look what we have here. Now we're just multiplying, so we add the exponents. B to the 1st times b to the negative 3rd is b to the 1 plus negative 3, which is b to the negative 2. So then we take that negative 2 and put it down in our denominator with a positive exponent. So you can see there's actually many different ways to solve these problems, but because this is a division and exponents worksheet, we're going to continue dividing, so we're going to be subtracting those exponents. And number 9, this one's actually quite simple. We have 8m cubed over 10m cubed. This m cubed is going to cancel out with that m cubed because there's 3 m's multiplied in my numerator and 3 m's multiplied in my denominator, so I'm just going to have 8/10 left, which 8/10 can be simplified down. Since both 8 and 10 are divisible by 2, we can simplify this down into 4/5. So my solution in number 9 is just 4/5. If you want to see that division and exponents work out, m cubed over m cubed is m to the 3 minus 3, which is m to the 0. And any base that's a real number raised to the 0 is going to be equal to 1. So m to the 0 is 1. And 1 times 8/10, when simplified down, is 4/5. Let's move on to number 10, the last problem on this first page. If you've been finding this video helpful, don't forget to click that like button and let me know in the comments below. But for now, let's finish out number 10. Number 10, breaking this fraction up, I'll have 7/2 times n cubed over n to the 5th. This is going to be 7/2, which can't be simplified down, times n cubed over n to the 5th is n to the 3 minus 5. 3 minus 5. So we're going to have 7/2 times n to the negative 2. What do we do with that negative exponent? We can write it as a positive as long as we move our base from the numerator into the denominator. So we're going to have 7/2 times 1 over n squared, which is 7 over 2n squared. Let's move on to that second page. In number 11, we have 2n squared all over n. So we're going to have 2 times n squared over n, which is just 2 times n to the 2 minus 1, or 2 times n to the first, or 2n. Looking at this visually, just to remember, we have 2 times n, that is 2 times n squared, all over n. One of those n's is going to cancel out in my denominator and numerator to leave me with just a 2n. Let's move on to number 12. In number 12, we have 8x cubed divided by 10x to the 5th. So this is going to be 8 over 10 times x cubed over x to the 5th. 8/10 are just my coefficients out in front of my x cubed and my x to the 5th. But 8/10 can be simplified down because both are divisible by 2. So this can be written as 4, and then we're multiplying that by x to the 3rd over x to the 5th, which is x to the 3 minus 5. From here, we get 4/5 times x to the negative 2, which we can write as 4 over 5x squared when we turn that negative exponent into a positive exponent. So 4 over 5x squared, 4 divided by 5x squared, is our solution for number 12. In number 13, we have 12x cubed over 9y to the 8th. But think about this. Do we have the same base? No, a base of x is not the same as a base of y. Those are not the same bases, so we're not going to be able to simplify those down. However, we can simplify down 12 and 9 because both are divisible by 3. So 12 divided by 3 is going to give us 4, and 9 divided by 3 is going to give us 3. Can we simplify down the x cubed? Nope, so that's going to stay as an x cubed. And again, we couldn't simplify down the y to the 8th because there was not another base of y in our problem. So that just stays as y to the 8th. So our solution is 4x cubed over 3y to the 8th. Again, I want to reiterate that the only way we can combine those exponents is if we have similar bases. So we could not simplify this problem down anymore besides just simplifying those coefficients. Let's move on to number 14. In number 14, again, we have two variables, except now we have x in the numerator and denominator, so we'll be able to simplify that down. And we also have y in the numerator and denominator, so we'll be able to simplify that down. And also, we have those coefficients out in front, which both are divisible by 2. So 14 divided by 6, I'm going to write as 7 over 3 because 14 divided by 2 is 7 and 6 divided by 2 is 3. And again, we can simplify coefficients down because all I'm doing is multiplying them by a positive 1. 14 over 6 times 1, where that 1 is really going to be a 1/2 over a 1/2. 1/2 divided by 1/2 is 1. 14 times 1/2, 14 divided by 2 equals 7. And 6 divided by 2, 6 times 1/2 equals 3. Again, I just multiplied by 1. 1/2 divided by 1/2 equals 1. And you can always multiply by 1 without changing the value. Sometimes you just have to get creative with what 1 you're multiplying by. And in this case, I multiplied by 1/2 over 1/2. Now, writing the rest, splitting up, I'll have x to the 4th over x to the 5th times y to the 7th over y to the 4th. So I'm going to have 7/3 times x to the 4 minus 5 times y to the 7 minus 4. This is going to leave me with 7/3 times x to the 4 minus 5 is x to the negative 1, and y to the 7 minus 4 is y to the positive 3. Remember, I only want positive exponents, so I'm going to put this x to the negative first in my denominator with a positive exponent. So we're going to get 7y cubed all over 3x to the first, or 3x. Now, the more you practice with this, the better you're going to get at understanding how some of these will get canceled out. For instance, I know that I have more x's in my denominator than I do in my numerator. And I actually have one more x in my denominator than I do in my numerator. So I know all of these will get canceled out and only leave me with one remaining in my denominator. So doing the subtraction in my head. Again, for my y to the 7th, there's more y's than my y to the 4th. So I know that all 4 of my y's in my denominator get canceled out, but that 7 minus the 4, if I cancel out 4 from this with all 4 in my denominator, then I'm only going to have 3 remaining in my numerator. So this 7 subtracting 4 will leave me with 3. And there we have it. 14 y to the 3rd, 6 x to the 1st, or 6x. But don't forget to simplify down those coefficients. 14 over 6 can be written as 7/3, so that's 7y cubed over 3x. So that's always a good way to double check your problems. Let's move on to number 15. For number 15, we have 11u to the 4th over 17u to the 7th times v to the 9th. I have my coefficients of 11 and 17. I have a base of u and another base of u, but then all I have is a base of v in my denominator. I don't have v anywhere else, so I know that v to the 9th is going to be in my final solution. But let's go ahead and simplify down these bases of u. My coefficients 11 and 17 cannot be simplified down, so I have 11 over 17 times my u to the 4th over u to the 7th can be written as u to the 4 minus 7. And then I have my v to the 9th in my denominator, so that's 1 over v to the 9th. I'll get 11/17 times is u to the negative 3 times 1 over v to the 9th. As we could have seen before we started this problem, because I have 7 u's multiplied together in the denominator and only 4 multiplied in the numerator, I'm going to have those u's remaining in my denominator, and I'm going to have 3 of them because 7 minus 4 is a positive 3, or 4 minus 7 is negative 3, where I need to put it in my denominator. So my final solution is going to be 11 all over 17 u cubed times v to the 9th. Let's move on to number 16. Number 16, I have a 4y to the 4th over 14y times x to the 8th. So you can see I have a common base of y, where the y in my denominator has an exponent of 1, and My 4 and 14 can be simplified down because 4 and 14 are both divisible by 2. So 2 is a factor of 4, and 2 is also a factor of 14. 4 divided by 2 is going to leave me with 2, and 14 divided by 2 is going to leave me with 7. Now, when I write my y to the 4th over y to the 1st, I can write that as y to the 4 minus 1. And my x to the 8th is just in my denominator, can't be combined with anything else, so I'll write that as 1 over x to the 8th. So I'll have 2 over 7 times y to the 4 minus 1, which is y cubed, times 1 over x to the 8th. Writing this back as one single fraction, I'll have 2y cubed all over 7x to the 8th. And if it's helpful, feel free to rewrite that y cubed as a y cubed over 1. It's the same thing as y cubed, but when multiplying your fractions, keeping those fraction bars in line, it's easy to see that the top, your numerator is going to be 2y cubed, and your denominator is going to be 7x to the 8th. So that's the solution in number 16. Let's move on to number 17. In number 17, 12 times y times x to the 4th over 10 times y times x to the 8th. Right away, I can see that my y is going to cancel out with my y. Y to the 1st over y to the 1st is y to the 1 minus 1, which is y to the 0, which any base raised to a power of 0 is equal to 1. So I can rewrite this entire problem as 12x to the 4th over 10x to the 8th. Now my 12 and my 10 are both divisible by 2. So 12 divided by 2 is 6, and 10 divided by 2 is 5. So I have 6 times x to the 4th over 5 times x to the 8th. Now that I've simplified down my coefficients, I can remember to combine those terms with similar bases by subtracting the exponents since this is division. So I'm going to have 6 over 5 times x to the 4 minus 8, which is going to be 6/5 times x to the negative 4, which is equivalent to 6 over 5x to the 4th, when I write that negative exponent as a positive. Now remember at the start where we talked about how the order matters in which way you subtract. So x to the 4 minus 8 is not the same thing as x to the 8 minus 4. However, x to the 4 minus 8 is the same as 1 over x to the 8 minus 4. Think about that for a second. So remembering this, if you really don't want to deal with negative exponents, figure out which exponent is largest and just write your subtraction where that occurs. So since I have 6x to the 4th over 5x to the 8th, where my x to the 8th has my largest exponent, I can write this as 6 over 5x to the 8 minus 4. Because I have 8 x's in my denominator and only 4 in my numerator, I know that my x's are going to be left in my denominator as positive exponents. So x to the 8 minus 4, that's 6 over 5x to the 4th. Now, if that confused you in any way, please just continue writing it out, splitting up the fraction, and subtracting those exponents, and then adjusting for those negative exponents. Now, I know I've been giving you lots of different explanations on how to solve these problems. I just want you to have lots of different tools in your tool belt so that if you see a problem and you're unsure of your answer, you can double check it a different way. You can think about, does this answer make sense in my head? I know that there are more x's in my denominator than in my numerator, so I should be able to cancel out those in my numerator and only have x's left in my denominator. You can think about that logically ahead of time and make sure that it checks out, or use it as a double check. But for now, let's continue on to number 18. So just as before, looking at number 18, we know that we have more x's in our numerator than our denominator, so those are eventually going to get canceled out. So we're not going to have any x's in our denominator, and We're also not going to have any y's because we only have y in our numerator and there's no base of y in our denominator. So let's start by first simplifying down our coefficients. 18 and 10 are both divisible by 2. 18 divided by 2 is going to give us a 9, and 10 divided by 2 is going to give us a 5. Then I have x to the 8th over x cubed, which is x to the 8 minus 3. And then that gets multiplied by y to the 8th. So simplifying this down, I have 9 times x to the 5th times y to the 8th all over 5. Because x to the 8 minus 3 is x to the 5th, y to the 8th remains as is, and 5 is the only number in my denominator. Let's move on to number 19. For number 19, we have 5 n to the 8th over 20 n to the 8th. Look what we got. N to the 8th divided by n to the 8th is n to the 8 minus 8, or n to the 0, which is just a 1. So here we have just our coefficients of 5/20ths, which can be simplified down because both are divisible by 5. 5 divided by 5 is 1, and 20 divided by 5 is 4. So 5 n to the 8th over 20 n to the 8th is equal to 1/4. Now on to our last problem on this worksheet, number 20. In number 20, looking at my bases in my numerator, I have an x in my numerator, and I also have an x in my denominator. Looking at my other bases, I have a y in my numerator and a y in my denominator. So I'll be able to combine both of those, and because we're dividing, those exponents will be subtracted. Now, can I simplify down my coefficients? No, I can't, because my factors of 9 are 1, 3, and 9, and my only factor in common with 16 would be that 1. 3 and 9 don't go into 16 evenly, so I have 16/9 still remaining as those coefficients. Now let's start with working out our x's next. X to the 4th over x to the 8th is x to the 4 minus 8. I know I'm going to have more x's in my denominator since I have x to the 8th, and 8 is bigger than 4, and it appears in my denominator. So when I work out this x to the 4 minus 8, I'm going to get a negative exponent. Then looking at y, I have y to the 1st over y squared, that's y to the 1 minus 2. Again, I'm going to have a negative exponent because I have y times y in my denominator and one single y in my numerator. That y in my numerator will get canceled out, leaving me with a y in my denominator. So I'm going to have 16 over 9 times x to the negative 4 times y to the negative 1. So this is going to be 16 all over 9x to the 4th times y. And there we have it. That's our final solution on this worksheet. If you have any questions at all, please feel free to leave them in the comments below. And as always, don't forget to like, subscribe, and share. Happy learning!